Hey everybody, this is Alex Merced from alexmercedcoder.com with another video. I've done videos sort of going over functions and callbacks before, but I'm going to do this is going to be a more longer video, especially with the callbacks, just kind of helping explain sort of how a callback works and what a callback is. But first we just need to discuss what a function is, okay? And again, a function in any programming language is just sort of a way to call sort of a bundle of code whenever you need it, okay? So there's different ways to write functions in JavaScript. The original way is you would do this. I would say, hey, function myfunc, and then I would do a parentheses, then I would do curly brackets, and then in the curly brackets, I would write down what does my function do. Okay? So in this case, all my function does is say hello. Okay? Now once I've defined the function, then I can actually use it. And the way you use or invoke a function is you would say myfunc, then you put the parentheses, and that's how JavaScript knows that you're using the function, not just referring to it. So if I just do this, this is just the variable that holds my function. It's not going to actually do it. It's just saying, hey, it's here. If I do this, then JavaScript's like, oh, you actually want me to do the thing. Okay, and then it does the thing. So watch. Save. So if I run this code, node testing.js, and see, it says hello. Okay, cool. Now, console logging stuff in your function isn't really useful. Logging is always useful for debugging, but at the end of the day, I want to actually have values that I can work with. So generally, you would prefer that your function returns a value. It gives you something back. So what I would rather do is that it returns the string hello. Okay, but now if I run this code, nothing's going to print on the screen because I didn't tell it to do anything with the hello that it gave me back. So what I'm going to do is I'm going to console log this function. So let me get rid of the semicolon for a moment, put some parentheses around this, console.log. So see, I'm invoking a function within another function. So I'm saying I want to log whatever the result of this is, but we don't know what the result of this is. So first it runs this function. It's going to get back the word hello, so then replaces this with hello, so it's going to console log hello. So now if I save it, cool. Okay, so and then a function only returns one thing. Okay, at least in JavaScript. There's other languages where you can return more than one thing, like Go. But this function returns one thing. And the minute that the function returns a value, the function stops. So if I put code like right after this, like if I put a console.log hello2, this code will never run because technically it's after the function has already returned a value, so the function just ends there. So say you never see hello2. Cool. But again, like I said, without the parentheses, it doesn't invoke the function. So if I take out the parentheses and I just try to log my func, what do I end up getting? See, I'm only logging the actual function itself. I'm not logging the result of the function. I'm logging the data that is the function. It's like, hey, look, this is a function called myfunc. Okay? So again, remember, without parentheses, I'm passing the function as a value versus actually invoking or using the function. It's kind of like I'm passing you the directions to do something, not telling you to actually do it. Cool. Okay, so that's now the thing is that functions get more fun when you can have them do different things with different data. So what if I don't want it? If I want to return a name, so it says hello. So you're going to pass a name to myfunc, and I can call this whatever I want. These are called parameters. Parameters are like a little placeholder names, and basically what's going to happen is I can name as many of these as I want and call them whatever I want. They become variables in my function definition that I can use to give direction. So I can say, hey, I don't know what name is yet because the user is going to tell me what the name is. But whatever name is, I want you to add it to hello. So you're going to return me the result of hello plus name. And that's what this function does. So now when I call the function, myfunc, I can then pass actual data. So when it's the variable, it's called a parameter. So this function has one parameter, which means that when I invoke the function here, I can pass it one argument. So in this case, I'll pass in the string Alex. Okay. Okay, so now when I go node testing, okay, so see, it now says hello Alex. Because when the function gets called, I'm passing in one argument, Alex. Alex then gets passed in and fills in whatever the first parameter is, which is name. So anywhere there's name in the function definition becomes Alex. So literally this becomes replaced with Alex. Okay? Does it have to be name? No, but these two would have to at least match. Okay, because basically Alex then replaces name, and then Alex is going to fill in anywhere where you saw name before. But I could have more than one parameter. Cool, so I can have name 2. Okay, so now I can do this. Name plus... Now I'll use interpolation here just to be fancy. And... space and name 2. So now I pass in a second argument, and we'll just say this is Jesse. I'll pass in the string of Jesse. So now what happens? Alex is the first argument, so it fills in the first parameter. So it's going to fill in name. Jesse is going to pass in name 2. Okay, name 2. Neat. Cool. So now, anywhere name was gets replaced with Alex, and anywhere name 2 is gets replaced with Jesse. So now when I run this, it should just say hello, Alex and Jesse. Huzzah! Yay! Okay, so that's just sort of basically how parameters work. And they don't have to be just one piece of data. They could be arrays. And then, like, if I want to be fancy, let's see here. I could do some. You could, if you've seen my videos on destructuring, this is something you can do with destructuring. So let's say I were to pass in an array, and it says Alex, Bob. Okay, so technically this is only one argument. Okay, because the array is one. Even though I have multiple pieces of data in the array is treated as one piece of data. Okay, and maybe I anticipate that you're going to pass me an array of names, and I only really want the first name. Well, then when I define my function, what I could do here is I can use destructuring. Okay, and I'll just sit there and say name. Okay, and the way this works is that it just takes when you use array destructuring, it always just takes the elements in order. So the first element in the array will get assigned to a variable named name. And you'll see this will end up working the same way. See, hello, Alex and Jesse. And what I could do, let's say I get rid of the second parameter. I'm going to get rid of the second argument here, and I do this instead. So if I do this, I'm destructuring the array that's being passed in. Now, if I pass in something that's not an array, it won't work. But again, that's my intention when I created this function. So Alex will get put into name, and then Bob gets placed into name 2. And now watch what happens. Hello, Alex and Bob. So you can do that. I can also do this as an object. So let's say I passed in it, instead of passing in this array, I passed in an object, and I pass in name Alex, name 2 Bob. Okay, I can use object destructuring in my parameter list. And again, you would only do this if you know that you're going to pass in an object or an array into this function. So you have to kind of know that ahead of time. It has to be, or if you're using a library where they intend you to do that, so they'll tell you about this in the documentation. But then I can just do this, name 2. Okay, and it will just pull those as separate variables from this object. So it's still, I'm only naming one parameter, and I'm only passing in one argument, but I'm able to break it down into for several variables to use in my function. Okay, this is just one of those areas where destructuring can be really useful. Okay, because oftentimes you'll have functions where you're being passed in chunks of data like objects and arrays, but having to type in, like, you know, the alternative would have been this. I can put in obj as my parameter name. Again, I could call it whatever I want, but now I would have to type in obj.name, obj.name2, and maybe I just want to save myself that typing. Okay, and I already know that there's going to be these name and name2 properties, so I just destructure it coming in. I mean, this technically, this way works the same way. Because see, I'm passing in this object here. This object gets stored in the object variable, and then I can call its properties using dot notation like any object. But again, with destructuring, you can have nicer, less typing with variables. It'll make your code more concise. If you're not familiar with destructuring, and that was kind of like a big mind break, well, watch my videos on destructuring. I have videos where I go like half hour on destructuring. It's a lot of cool stuff you can do with it. Cool. So that's a pretty good lesson on just sort of functions. There's different ways I could have designed this function. Okay, I don't have to use this syntax. Nowadays, most of the time what you do is you're assigning it to a variable instead of just using this function keyword. So I could do like const myfunc, and then it would be like equals either function obj. So this would do the same thing. I'm just saying this function will be assigned to this variable myfunc. See, still works. And then the newest way to do it is I can get rid of this function keyword, which saves me all those letters of typing. And instead, I would just put an arrow here, and that's what's called an arrow function. There are some differences between when you use a function keyword and you use an arrow function, but I would refer you to my functions masterclass video where I go very in depth about that. We're going to want to come back to the callbacks today, so I don't want to spend too much time on this particular nuance. So hello, Alex and Bob. So it still works. So no matter how I define it, a function works as a function. Okay. The only real difference between function and arrow functions would be when I'm not using it, the old functions as a function. And I want to do like classes and stuff. But again, watch that other video, the functions masterclass. Cool. Now let's talk about callbacks. So a callback is a function that takes a function as a parameter. So let's imagine this. Let's actually recreate an array function. So I'm going to create a function. So basically there's a function called map where you can, do a function on every element of an array. How would I recreate map? Okay, so we're going to do a const new map. So this is just a new version of the map function. Equals. We're going to pass in an array and a callback. So those are our two are going to be our two parameters in this function. Okay. And what does this function do? Like, what does map actually do? Map just takes your array, takes a function, runs that function on each element of your array, and then returns you an array of the result. Okay, so we just have to do exactly that. So first we need to loop over the array. So for that we can just use a for loop. So we'll just do for so I'm going to use index just to be explicit. So index equals 0. Okay, as long as index is less than the array's length, array.length, just keep looping. Okay. Cool. Now we're looping over the array. Now the thing is that we're going to need to have a new array because you're going to return a new array to the user. So first we need to declare a new array. So we're going to say const new array equals an empty array, just so we have that. And then every loop, you're going to run the function that the user gives you, which is going to be the callback parameter. We don't know what that is yet, but we know they're going to give us a function. We're going to run the value of that array on that function, and it'll return a thing. And we're going to push that into our new array. So every time this thing loops, we're going to take our new array, we're going to push a value into it. Now what value are we going to push into it? Whatever the user's function gives us back. So that's the callback function. Again, we don't know what that function is yet because the user hasn't given it to us yet. But we know whatever that function is, we're going to pass two things into it because that's how we're designing this. Every time I'm going to first pass in the value. So I have to actually, let's see here, that would be r dot r and then whatever the current index is, which makes me realize I have to fix this over here. Index. Okay, so basically each time this loops, it's going to send whatever the current item in the array is into this function. Now typically in your callbacks, into your high order array functions, usually the first thing you pass in is the value from the loop, the second thing you're passing in is index. So that way the user has access to the index. Okay, but literally it's just going to run this function. Whatever it returns gets pushed into the array. And then once this loop is over, it's going to return that new array. And there you go. That's map. That's literally it. Okay, well, so when you use map or for each or sum, it's some sort of variation on this story. So that's the underlying function that takes a callback. So that's the function. That's what's called a higher order function. Okay, so this function can do a lot of things depending on what function I give it. So that's why it's called a higher order function, because essentially what it does, it acts as a wrapper around another function. So whenever you hear the term higher order, it always just really means it's a wrapper. Okay, you're going to take something else and wrap this around it. So let's say here I have my function const, because what I want to do, let's actually make an array first. Const my r equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And now what I want to do is I want to add 1 to each of those items. Okay. But I want to design it to be used in map. So I'm going to create a function called add1. So it's going to add 1 to whatever you give it. Add1 equals, now since we're going to use this in map, we have to kind of understand how map works. So we have to kind of read the documentation that whenever we pass a function into map, that the first thing we're passing in is the value. So I'm going to just label this value just because it helps me think through it. And the second thing that's going to be passed in, the second argument that's going to be passed in is the index in the array. So I'm going to say index. This just helps me think through what my function is going to be doing going forward. Okay, and all it's going to do is going to take whatever the current value is, add 1, and again I'm going to return that value, and that's it. That's the function. Okay, all it does is literally add 1. You know, I could use this function by itself. I could just pass in a value and it'll add 1 to it. So I could use it by itself, but by passing it into map, map will take the extra step of then using it on every element of the array. That's the beauty of it. Instead of me having to create one function that does both, I can have one function that always does something on every element of the array, map. So then I only have to create a function for what I want done to one thing. So it allows me to have a sort of a more modular approach where I don't have to type in this logic every single time. I just have to worry about creating this logic. Okay, because this will always act as a wrapper I can insert the smaller bit of logic into. So now let's just try it out. So let's invoke the new map function. Well, we want to console log the results, so let's do a console.log. Okay. So what we're going to do is we're going to use the new map function. Now the new map function takes 2 arguments, the array. So that array is called myR. And then it takes a function, the callback. Then again, a callback is just a function that's being passed into another function. So my callback in this case is add1. Okay. Cool. Save. Now if I run this, we should just get back the original array 1 through 10, but all with 1 added to each item. And that's what we got, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because what happens is that we pass in my array, which becomes R in new map, and then we pass add 1, that becomes the callback. So then it creates a new array and then loops over the array we passed in. So it's going to loop over R, and then the very first time it passes in 1 and then uses the add1 function. So this callback becomes add1. So does the add1 function on 1, pushes that into the array. Does the add1 function on 2, passes it into the array. Okay. Now how am I supposed to know when I design my callback function that this is going to be value then index? I don't know. By magic. You have to read documentation. So the reason I know like map works this way and all the built-in JavaScript higher order functions work this way is because I had to read it. Okay, I had to go look in the documentation. When you use other libraries that have callback functions, like when you use Express, and it's always the request object and res inside the callback, the only way you would know that is if you read the Express documentation. Okay, because you have to learn how the person designed the function to know what they passed in, what what argument do they expect to be passed in first versus what argument they expect to be passed in second. Then the labels don't matter. I could call this cheese for all I wanted to. I could have just done cheese, cheese. This would still work the same, okay? Because this is just a placeholder when I define a function. But when the time comes, again, the actual argument is going to be this, passed in by this function. So again, a function that calls another function is called a callback. And the reason why you generally use callbacks is to do with this pattern called a higher order function, where you have a function that does a big chunk of logic that's repeated. You know, like, again, in this case, running a function on each element of an array. So that logic is taken care of. Now all I have to do is fill in the gap. What function do I want run on every element of an array? And you can do this for kind of any situation. But the idea is if you have a task that you can break down into two sets of logic, then it makes sense to have less code to sit there and figure out a way where you can create a wrapper function, a higher order function, where you can just put in little mini functions, so that way you're only doing half the work half the time, instead of doing the whole thing and defining all the logic every time, which is just, you know, doing extra work for the sake of doing extra work. So hopefully that makes callbacks make a little bit more sense. Okay, now one thing to keep in mind also is when functions are invoked in other functions, the most recent function, this is what's referred to as a call stack. So in this case, when this function runs, okay, what happens is that the new map function runs, and that gets added to the stack of functions that need to finish. But then in the middle of new map, we call add one. Okay. So basically what's going to happen is that this add one function has to finish first. So this add one function, because it got called afterwards. So this add one function has to finish, then new map will continue. But again, we call add one several times, so it keeps pausing new map every time add one runs. So once that's done happening, then new map finishes. The idea is the deeper you go, the deeper function has to finish first. And the reason why that's important to understand is to understand what order certain things are going to happen in your code when you start getting into really complicated, like nested functions, where you have functions nested in functions nested in functions. This is where you kind of end up with something called callback hell, where you're passing one callback into another callback into another callback into another callback. So you end up with this sort of like pyramid-like structure. Hopefully this makes this make more sense. And then so you can see, like map, like a cool, really useful function like map isn't necessarily a lot of code, because it's only handling a very small piece of your logic. The idea of literally the logic that new map handles for you is giving you a new array and then pushing the result of a function you give it into that array for every element in that array. So literally, and that's pretty much how all these, like filter, sum, every, they're all kind of designed this way. So yeah, hopefully this gives you some ideas, some tools to be able to create your own higher order functions, or at least have a better appreciation of how to use them. My name is Alex Merced from alexmercedcoder.com. If you want to learn what are the different array higher order functions, I do have a video just on that somewhere. So just look, I think it's in the array master class. And have a great day and enjoy. And thank you very much.